Good evening, everyone. Today, let me discuss the concept of permutations and combinations, which will be useful for you. Is that? Yes. So which is there in your first PUC? Let me start. What is called permutation? Before going to teach permutations and combinations, first of all, you should know the meaning of fundamental principle of counting. Fundamental principle of counting. If a work is done in m ways, another work is done in n ways, the two works simultaneously can be done in mn ways. This is called fundamental principle of counting over multiplication. If a work is done in m ways, another work is done in n ways, the two works, either of the two works, either first work or second work or both, either of the two works can be done in m plus n ways. In one problem, if you want to take, if a work is done in different types of ways and if you want the work to be done together, means, for example, I want to arrange 5 boys and 5 girls alternately, or if I want to arrange 5 boys and 5 girls such that all boys come together like that, then it will be like mn ways. If I want to arrange the same question, if I want to arrange 5 boys and 5 girls alternately, then it comes m plus n. Means, if you want to take some cases in one problem, then you should use m plus n. If the works to be done together simultaneously should be given by mn ways. I conclude these 2 points. If a work is done in m ways, another work is done in n ways, the two works simultaneously can be done together in mn ways. If a work is done in m ways, another work is done in n ways, then either of the two works can be done in m plus n ways. These two are said to be fundamental principle of counting over multiplication and over addition. Right? Next one. Factorial notation. As you know very well that 1 plus 2 plus 3 plus and so on plus n is equal to sigma n, where sigma represents summation. Similarly, 1 into 2 into 3 into 4 and into so on, n is equal to n factorial. The product of first n natural numbers gives you the value of n factorial. Right? Now, or if we go through the descending order, n into n minus 1 into n minus 2 and so on, 4 into 3 into 2 into 1, which is equals to n factorial, or you can call this one as n factorial. Factorial n. The value is same, but the symbol is different, right? Now, if you go through the descending order, it is factorial n, and if you go like this, it is n factorial. The meaning is same and the value is same, but the symbol is different, right? That is the thing. Now, let me enter into the concept of permutations. What are called permutations and how many types of permutations are there? Easy problems, you are going to get one question or two questions from permutations and combinations, even in your CET or in JEE. Now, permutations. The arrangement of things are called as permutations. Arrangement of things are of two types. One is linear, another one is circular. What are called linear permutations? The permutations, that means the arrangement of things in a line, means either row wise or column wise, is called linear permutation. I repeat, linear permutations are the arrangements in which the things are arranged in either row wise or column wise, right? Circular permutation, the arrangement of things circularly, means around the table or like that, then it arranged among themselves. N things can be arranged among themselves in n factorial ways, as you know very well. And among n things, things are taken and arranged in NPR ways when repetition is not allowed. When repetition is not allowed, among n things are taken and arranged in NPR ways where P represents the permutation. In NPR, n is always greater than or equal to r. Now, when repetition is not allowed, among n things are taken and arranged in n to the power of r ways when repetition is allowed. Right? Among n things are taken and arranged in n to the power of r minus npr ways when at least one is repeated. At least one thing is repeated. At least one thing is repeated. Now let us go through some examples of this synapses. Of this concept. First one, I am going to give you one question. In how many ways can the letters of the word be arranged by using all the letters of the word victory? In how many ways can the letters of the given word be arranged by taking all the letters 1, 2, 3, 4, 5, 6, 7. First of all, you should check if any letter is repeated or not. In the given word victory, there is no letter repeated, right? That means there is no letter alike. Same letters are not there. Hence, 7 letters, 7 different. Here it is n dissimilar things. N dissimilar. Not similar. N dissimilar things can be arranged among themselves in n factorial ways. C means the first problem, the first synapses. 7 letters can be arranged among themselves in 7 factorial ways. 7 letters are dissimilar, right? Now the second question. In how many ways can a 4-letter word be formed by using all the letters of the word victory? He asked you 4-letter word when repetition is not allowed. N is equal to 7. he asked you a 4-letter word. R value is equal to 4. Right? So therefore, NPR, when repetition is not allowed, 7P4, which is equal to 7 into 6 into 5 into 4. You can ask me what is the explanation, sir? 4-letter word he asked. So 1, 2, 3, 4. 4-letter word occupies 4 places. The first place can be filled in 7 ways. The second place can be filled in 6 ways. The third place can be filled in 5 ways. The fourth place can be filled in 4 ways. Where 7 into 6 into 5 into 4 can be written as 7P4. Okay. Now the third one. When repetition is allowed, the same question. In how many ways can a 4-letter word be formed by using the letters of the word victory? I repeat the question. In how many ways can a 4-letter word be arranged by using all the letters of the word victory? How many letters are there? 7. So here, see, n is equal to 7. Required letter word R is equal to 4. Now, n to the power of R is the formula. Am I right? So, n to the power of R is the formula, which is equal to 7 to the power of 4. The example, that means the explanation for this one. There are, that means 1, 2, 3, 4-letter word he asked you to find. Repetition is allowed. You can fill up this in 7 ways, right? Suppose if I fill up this place with V, right? That V letter can also come in the next 3. So again 7, again 7, again 7. Therefore, the required number of permutations are 7 to the power of 4, right? Now, the next question it is, fourth question solution I am going to write here. Among n dissimilar things are taken and arranged in n to the power of r minus npr ways when at least one thing is repeated. At least one thing is repeated means n to the power of r, 7 to the power of 4 minus 7p4 ways. Right? Before going to teach this, let me discuss n p1 is equal to n. Np2 is equal to n into n minus 1. 2 terms back, 2 consecutive terms back. Similarly, Np3 value is equal to n into n minus 1 into n minus 2. Obviously, Np4 is equal to n into n minus 1 into n minus 2 into n minus 3. 4 terms back, right? So, this is the way how to do the problems of permutations, linear permutations. N dissimilar things can be arranged in n factorial ways. Among n things are taken and arranged in npr ways when repetition is not allowed. Like this. Among n dissimilar things are taken and arranged when repetition is allowed. N to the power of r. And among n things are taken and arranged in n to the power of r minus npr ways when at least one thing is repeated. 7 power 4 minus 7p4. Yes, I hope you understood all these points, right? Now, let us go through the problems of, you just observe that one for a while. I am going to rub the board. You just observe for 1 minute entirely. Yes, I hope you have observed that entire 4 problems, right? Now, how to do the problems when he asks you to be together and not to be together. Second model. This is first model problems in permutations. Second model problems. Together, that means come together, do not come together. Right? To come together and do not come together. How to do the problems of this one? Same question, same example I am going to give you by taking same word. Suppose, let me write the question first of all. After that, easily you can understand. In how many ways can the letters of the word victory be arranged such that, first problem, all vowels come together, no two vowel come together, right? All vowels do not come together. Yes. See the problem what has been given to you. In how many ways can the letters of the word victory be arranged such that all vowels come together? Second one, all vowels do not, no two vowels come together. No two vowels come together. There is a lot of difference between each and every problem which has been given here, right? Now, same victory. The given word victory consists of 7 letters. Therefore, n is equal to 7. Right? How many vowels are there? Vowels is equals to 2. I, comma, O. And remaining are consonants is equal to 5. Right? Now he asked you the first question. He asked you all vowels come together. If any quantity is to come together, then you should consider that quantity as one unit. That means here consider these two vowels as one unit. Means I, comma, O as one unit. Right? Plus remaining 5 as 5 units. Remaining 5 as 5 units. 1, that means 1 plus 5 is equal to 6 units. 6 units can be arranged among themselves in 6 factorial ways. Like n things can be arranged among themselves in n factorial ways. 6 units can be arranged among themselves in 6 factorial ways. Here you are having 2 vowels. These two can be arranged. See here, I is in first place, O is in second place. Now I can interchange them and I can arrange this O comma I also. Means these two can be arranged among themselves in 2 factorial. So the answer of the first problem, all vowels come together, is 6 factorial into 2 factorial. I repeat this problem again. Whenever you want to make one quantity to be together, you just consider that entire quantity as one unit. Here, two vowels as one unit, okay, plus remaining 5 consonants as 5 units. Therefore, 1 plus 5 is equal to 6 units. 6 units can be arranged among themselves in 6 factorial ways. After that, there you can arrange these two vowels in 2 factorial ways. So 6 factorial into 2 factorial. The second one, no two vowels come together. No two vowels come together. So when you want to make no two vowels come together, you just keep that entire quantity, vowel quantity aside. Keeping that vowel quantity aside, we will have 5 consonants. 5 consonants can be arranged among themselves. See here, 1, 2, 3, 4, 5. 5 consonants can be arranged among themselves in 5 factorial ways. 5 consonants can be arranged among themselves in 5 factorial ways. Right? And listen, this is consonant, this is consonant, this is consonant, like this. Okay? 5 consonants can be arranged among themselves in 5 factorial ways. There are 1, 2, 3, 4, 6 places. There are 6 places for 2 vowels. This can be arranged in 6 P2 ways. I repeat the second problem explanation. No two vowels come together. You just keep that vowels quantity aside. Leaving that vowel quantity aside, we will have 5 consonants, 5 different consonants, right? So 5 consonants can be arranged among themselves in 5 factorial ways. Then there will be these into marks represents the places which are vacant, which we can fill the vowels. See here, one, either you can fill one vowel here, another vowel here, or one vowel here, another vowel here, or like that. So there will be 1, 2, 3, 4, 5, 6 vowels, 6 places. There will be 6 places for 2 vowels. This can be filled in how many ways? 6 P2 ways. As you know, the 5 factorial value is equal to 120 into 6 into 5. 6 P2 value is equal to 6 into 5. Okay, you can simplify it as usual. Next, third problem explanation I am giving here. All vowels do not come together. Means total permutations minus vowels come together. There is a lot of difference between second problem and third problem. All vowels do not come together. Total permutations minus vowels come together. Total, how many permutations are there? 7 things can be arranged among themselves in 7 factorial ways. N factorial, 7 factorial. So total permutations are 7 factorial minus vowels come together means first problem means 6 factorial into 2 factorial. This is the way how to do the problems when you want to when you want one quantity to be together and not to be together. Okay. Now copy this or you just take the screenshot of this one for a while. Give me 1 minute time and let me discuss another topic of alike things in permutations. Yes. Next concept it is problems on alike things. Alike means similar. Yes, how to do that similar and what is that similar part. I hope you have, I think you took the screenshot of this one, right? Now the third concept of linear permutation is alike things. Problems on alike things. What is the meaning of alike? Alike is nothing but similar. In the previous problem, we discussed the problems on dissimilar things. Now, what was the synopsis actually? Observe, n dissimilar things can be arranged in n factorial ways. Okay. For example, now itself I have given VICTORY victory, right? The word victory can be arranged in how many ways, which is equal to 7 factorial. In this word, no letter has been repeated, right? Suppose if I ask you the question, in how many ways can the letters of the word CHEESE, cheese, be arranged? See, in this word, there are 3 E's, right? So, how to do this type of problems? That is nothing but alike things. Alike means similar. Okay. Now, if any similar letters or any similar digits comes to your notice, then you should use this formula. What is that one called? If among n things, if p things are of one kind, q things are of second kind, r things are of third kind, then the required permutations is equal to n factorial upon p factorial into q factorial into r factorial. Have understood now? I repeat. Among n things, if p things are of one kind, q things are of second kind, r things are of third kind, then the total number of arrangements required is equal to n factorial by p factorial into q factorial into r factorial. Similarly, if you observe this one, in how many ways can the letters of this cheese, can the letters of the word cheese be arranged? See here, there are 1, 2, 3, 4, 5, 6. So n value is equal to 6. Number of E's is equal to 3. Number of C is equal to 1. Let me consider it as P, it as Q. Okay. Number of H is equal to 1. Let me consider this one as R. And number of S is equal to 1, which is equal to capital S or small s, whatever it may be, or T. So, according to our synopsis, it is 6 factorial upon 3 factorial into 1 into 1 into 1. Okay. Q factorial, R factorial, T factorial. 1 into 1 into 1, ignore it. So, the arrangements, the required arrangements are 6 factorial upon 3 factorial you are going to get. I conclude the problems on alike things. Among n things, if r things, if p things are of one kind, q things are of second kind, r things are of third kind, then the required number of permutations is equal to n factorial upon p factorial into q factorial into r factorial. You take the screenshot of that one. I took one example. Of course, you are going to get the problems on this one. Take down this problem. Take the screenshot of this. Now I am going to share the exercise. Yeah, I'm sorry. 8PR is equal to 8PR plus 1. I am going to explain it. 8 factorial by 8 minus R factorial is equal to 8 factorial by 8 minus R plus 1 factorial, right? Now, by doing cross multiplication means here you are going to get 8 minus R minus 1 means 7 minus R factorial is equal to 8 minus R factorial. 7 minus R factorial is equal to 8 minus R into 8 minus R minus 1 is equal to 7 minus R factorial. Cancel. 8 minus R is equal to 1. R is equal to 7. Now the next question is waiting for you. NP7 is equal to 42 into NP5. He asked you to find out the value of N. Now NP7 is equal to, you can do this problem by using two methods, three methods. The first one, it is normal, called N into N minus 1 into N minus 2 into N minus 3 into N minus 4 into N minus 5 into N minus 6. 1, 2, 3, 4, 5, 6, 7 times, right? Is equal to 42 into N minus 1 into N minus 2 into N minus 3 into N minus 4. Both sides up to here it is cancelled, right? Now N into N minus 5 into N minus 6 is equal to 42. By simplifying this, we are going to get N value is equals to, here N minus 5 is equal to 7, we are going to get N is equals to 12. Or simple way, substitute N is equal to 12 in the options given to you. 12 minus 5, 7. 12 minus 6, 6. 7, 6 are 42. So answer is 12. Okay, copy this one. Sir, you can ask me, sir, suppose NP12 given to you, sir, what to do? Means second method it is applicable. What it is called? What is the second method, sir? N factorial by N minus 7 factorial, NP7. N factorial by N minus 7 factorial is equal to 42 into N factorial by N minus 5 factorial. Both sides N factorial get cancelled, right? Now, if you reduce that one, you are going to get N minus 5, N minus 5 minus 1, N minus 6, N minus 6 minus 1, N minus 7. So just do the cross multiplication. We are going to get N minus 5 factorial is equal to 42 into N minus 7 factorial. Just do the verification by substituting N is equal to 12 here. Right? So 12 minus 5 factorial. Okay, that means see here you are going to get, observe, N minus 5 factorial can be written as N minus 5 into N minus 6 into N minus 7 factorial is equal to 42 times of N minus 7 factorial. Both sides get cancelled. Again, you are going to get the same and put N is equal to 12. Okay, easily you can copy this one. Yes, observe the third problem on the screen. (12PR) is equal to 11P6 plus 6 into 11P5. Then find the value of R. (12PR) is equal to third problem. 12PR is equal to 11P6 plus 6 into 11P5. Then find R. We are having one synopsis like NPR plus R into NPR minus 1 is equal to N plus 1 PR. So by comparing, observe 11P6 plus 6 into 11P 6 minus 1 is equal to 5 is equal to 12PR. Therefore, by comparing, we are going to get R value is equal to 6. Copy this one. I hope you have copied it, and tomorrow let us discuss some more problems. Thank you. Have a